Morning, everybody. Woo! So it's the first session for reInvent, and everyone is still here, still awake, mostly sober looking, so we're off to a good start. So this session today is going to be about navigating HIPAA and HITRUST, and we're going to be talking about a couple different areas for how you can actually implement healthcare solutions on top of AWS. To kick things off, I want to make sure that everybody feels like they're in the right place. I would rather you leave disappointed now than angry at the end. This is an advanced session. So this is a 300-level session, and by the AWS reInvent terms, what that means is that generally you already have a good understanding of common AWS service terminology. So we're not going to explain what EC2 is, EBS, VPC. If you're not familiar with this terminology, the track session is a little bit more advanced. You're really here because you get it and you want to learn more, so you're actually trying to build out a solution right now, or you're actually in the process of building on it, and you're trying to enhance it. So quick summary of some of the healthcare topics that we're going to cover today. The first one, if you're not familiar with it, is HIPAA. It's a Health Insurance Portability and Accountability Act. Really, the key tenets here is that for 45 CFR Part 160 outlines the actual HIPAA regulation. The way that you actually implement the controls is through NIST 866, and we use 853 as a crosswalk for 866. On the other side is HITRUST. So where HIPAA was a government-mandated regulation, HITRUST came from a sort of a public sector consortium of folks that got together in this alliance. It was founded in 2007. It uses a common security framework, so it's using frameworks like NIST, PCI, ISO. It's a little bit more modern, a little bit more specific in the way that they want you to implement controls, whereas HIPAA tends to be a little bit more general in terms of, this needs to be enabled in a particular way. So when we start this session today, what we really wanted to do, rather than have Amazon folks up here talking, is I wanted to give you guys an opportunity to hear what customers in the field are really doing. So we're really honored and really happy that the folks from Beth Israel came out here. What we're going to be doing is bringing up Chuck Fuller. Chuck's going to talk about their roadmap and what they're actually doing on AWS today.
Thanks, Brad. Good morning, everyone. My name's Chuck Fuller, and I'm an infrastructure architect with Beth Israel Deaconess Medical Center. Today, I want to share with you how we've secured a number of the foundation services that we use on the platform. Before I begin, I just wanted to quickly give some background information on the medical center. So we're a private, nonprofit teaching hospital of Harvard Medical School, and we're located in Boston. Our areas of focus are clinical care, teaching, and research. We have about 1,250 physicians on staff, 671 licensed beds. We have an innovative residency program, and we receive about $230 million a year in research funding. So why the cloud? The lease on our main data center is set to expire in about 5 years, and we need to find an alternative. So of all the options we looked at, the cloud made the most sense. We want to become more agile and innovative, and have an instant access to the broad range of services available on the cloud will allow us to do that, in addition to support many of the emerging healthcare trends, such as increased collaboration, mobile engagement, telemedicine, and the rise of big data and analytics to support and achieve better clinical outcomes. Our DR data center is within about 2 miles of our primary data center. So to reduce risk with that, we're moving DR applications to the cloud. And we look at the cloud as an opportunity to improve our security posture. And AWS specifically, we will be able to build a secure environment from the ground up, leveraging all the baked-in security tools of the platform. And this is a list of services that we currently use. We use all the core foundation services. We use some messaging services, SNS, SQS, a handful of management services, and security and compliance services, the IAM and key management service. One service I would like to call out here is CloudFormation specifically. We use that to automate the deployment of our resources. But we also look at it as a way to ensure consistent security configurations across our environment. And here's what we're doing around account security. So when we built out our first account, there was a requirement that all PHI workloads needed to run on dedicated instances. and there's a $2 per hour per account charge for that. And so we weren't willing to pay that for multiple accounts. So we started out with a single account. And about 6 months ago, that requirement was waived, and we've since started building out additional accounts. So you'll see that we have 4 accounts. We have a production account, a dev test account, we have an Explore IT account, which is an isolated sandbox where staff can go to experiment with new technologies. The activity in this account doesn't require connectivity back to internal data or systems. Then we have a grant account for any grant work that doesn't fall under our the consolidated billing model and process of our other accounts. All our accounts use multi-factor authentication. We secure our root user credentials by having one IT team manage the password and another IT team managing the physical token. All other IAM users use token apps on their phones, such as Google Authenticator or OpenOTP. We've also implemented Identity Federation using SAML 2.0, and this allows our users to log into AWS with their Enterprise Active Directory credentials. And this is our Identity Federation architecture, which this is a single sign-on solution that leverages our enterprise identity provider, which is integrated with our Active Directory and has a trust relationship set up with AWS. In this configuration, the user-to-role mapping occurs on the identity provider. And how this works is the user will open a browser to the identity provider's portal page. The user credentials will be authenticated against Active Directory, and then the identity provider will generate a response that includes SAML assertions, which identify the user, and attributes, which identify the roles. The browser is then redirected to the AWS single sign-on endpoint, where it posts the SAML assertion, and then the endpoint will return a sign-in URL, which redirects the browser to the AWS console, and the user will assume the role that was provided during this process. If a user is granted multiple roles, at this point, the user will be able to select which role they want to assume. We have roles for each of our IT operations teams. So for example, the network team has a role that allows full access to VPCs, Direct Connect, and Route 53. This is what we're doing around VPC security. So we have a hub and spoke VPC design. Our hub VPC contains all our shared services such as DNS, Active Directory, Bastion host, logging, etc. Our spoke VPCs are created based more or less on lines of business and application type. So we have a VPC for clinical, we have a VPC for research, a VPC for big data, etc. This provides a network layer boundary between applications that shouldn't talk to each other. We have a 10 gigabit direct connect back to our primary data center, and we have backup VPN tunnels to our DR data center. VPC flow logs provides flow level visibility into the communications of each instance. We use it to troubleshoot connectivity issues to see if a security group could be blocking the traffic. And this is a diagram that illustrates much of what I just talked about on the previous slide. You'll see we have a private virtual interface configured directly into each VPC across the Direct Connect circuit. We have backup VPN tunnels that terminate directly into each VPC. Our shared services VPC is connected to our spoke VPCs using a VPC pairing connection. And this is how resources in the spoke VPC can communicate with the shared services. You'll see we don't have any IGWs connected to our VPCs, and we backhaul all traffic to on-premise. And so all of this makes up the foundation of our hybrid data center. For EC2 security, we encrypt our AMIs and data volumes using customer-managed keys, which are created with AWS's key management service. We have Bastion host and our shared VPC, and we require all administrative access into our instances to go through these Bastion hosts. We enforce this with security groups on the instance level. So a security group will only allow RDP and SSH, for example, to come in from these Bastion hosts. If a user tries to directly connect to an instance using RDP or SSH, the security group will block that traffic. And then each of our instances has several security groups applied. Security groups, for those who don't know, are layer 4 stateful firewalls that are applied at the network interface of each instance. As I mentioned before, we use CloudFormation to automate the deployment of our resources. This is a snippet from an EC2 template that shows an encrypted EBS volume being created. And you'll see that the encrypted property there is set to true. And this is our security group architecture. So we have two types of security groups. We have a shared services security groups, which are on the left in blue, and application security groups, which are in red. The shared security groups permit all the IPs and ports necessary for the shared service to communicate. And the application security groups permit all the IPs and ports necessary for the application to communicate. So if you look at the core VPC, you'll see each shared service tier has a dedicated shared service security group attached to it. And down on the bottom left in the spoke VPC, you'll see a corresponding shared services security group. These are pre-configured and pre-approved by IS Security and are available to attach to any instance that gets created immediately. For the application security groups, we configure a security group for each tier of an application stack. So a three-tiered security group, a three-tiered application stack rather, would have three security groups. A web security group, an application security group, and a database security group. Both types of security groups use this technique called security group chaining, where the rules in the lower tier security group refer to the security group ID of the higher tiered security group. And this provides for a logical flow of traffic down through the application stack and allows us to adhere to the principle of least privilege in our rule sets. So if you look on the right, you'll see that this would be an example of a secure web connection coming in from on-premise. You have port 443 being permitted into the ELB tier, which gets passed through down to the web tier. And if you look at the red arrows, this illustrates it the best, those red arrows. And then the web tier will pass the necessary ports down depending on what type of application it is to the application tier. And then depending on the database, the correct database port is allowed in. And this is a snippet from one of our CloudFormation templates that builds a couple shared services security groups. So on the left, you'll see the definition of those security groups. And you'll see the VPC being selected for each one. And then on the right, you'll see the ingress rules. On the lower right, you'll see a DNS rule that's allowing port 53, and it refers to the source security group ID of the DNS servers in our shared services VPC. And for S3 security, we use a bucket policy to enforce encryption and filter by source IP address. We use IAM roles to enforce permissions. So the storage team has full access to S3, and other admins and developers have read-write access as needed. And then for each S3 bucket, we enable monitoring. We enable access logs for monitoring purposes. And this is an example of one of our S3 bucket policies. So on the left, you'll see the configuration that denies the upload of an unencrypted object. This is the method that we're using right now. There is a new feature that just came out a few weeks ago. It's called default encryption that actually will encrypt objects as they're uploaded to a bucket. So rather than rejecting them on the upload, they'll actually get encrypted as they're getting uploaded to the S3 bucket. So that's something we'll probably look to move to moving forward, as that seems to be a better way to handle that rather than just rejecting the upload outright. And then on the right, you'll see the configuration to filter by source IP. And this is basically comes into play if S3 bucket becomes public. We restrict it by default to our corporate public IP space. And so some of our challenges were we wanted to put layer 7 firewalls into each one of our VPCs, but because of our distributed network design, we would have needed too many firewalls. And at the time, there wasn't a built-in AWS solution for us to use, so we would have had to rely on third-party solutions and would have had to purchase licenses and pay for the EC2 cost to run these virtual firewalls. So that wasn't something we were looking to do. In addition, our routing would have become very complex because we needed to route the traffic both inbound and outbound through these firewalls. So we made the decision to put a firewall on-premise in line with our direct connect circuit. And that gives us full application visibility into control into all traffic entering and exiting our VPCs. As we started to build out additional accounts, it became obvious that managing local IAM users would not scale well. So that led to the federated identity federation architecture that I mentioned earlier. We found out we couldn't copy encrypted AMIs between accounts, but we learned about a workaround where you can share an encrypted EBS volume. and then re-encrypt it in the destination account, and then build and register an AMI from it. And then there are a few services that we wanted to use, such as Lambda and WAF, that weren't HIPAA eligible. And so we either had to delay implementing that solution or come up with an alternative design that didn't rely on that service. That being said, services have been rapidly becoming HIPAA eligible over the last year, so we haven't had to wait long to be able to do what we want to do. And in terms of next steps, we're going to evaluate AWS organizations. So AWS organizations is a policy-based management solution for multiple accounts, and it allows you to set policies at the account level. So for example, you can restrict an entire account to only be able to access certain services. So we're going to go in and evaluate our business units, specifically maybe our research community and our community hospitals, and see where this might bring value. We want to extend our identity federation coverage, so we have it working with the AWS console, as I covered previously. Now we want to get it working for the AWS CLI and our API interfaces. We're looking to build a central security account, which would simplify our identity federation configuration by only allowing us to, or only requiring us to integrate one account with our identity provider. And in this solution, all user access would come through this central account. The federated user access would come through this central account. And then we would use cross-account roles to access all the other accounts. We will also be able to centralize our logging, collection, and analysis by creating an S3 bucket in this central security account and pointing all logs from our other accounts to this bucket. And then it was recently announced that Lambda became HIPAA eligible. So for those who don't know, this is a service that allows you to run code without configuring any servers. We have a number of use cases for this, specifically around our mobile application services. So we're currently working on secure architectures for a number of applications that will use the built-in security of this Lambda service, which include execution permissions, invocation permissions, and security groups, which get applied to the network interfaces of the Lambda functions that connect to our VPCs. So with that, I'm going to hand it back to Brad, who's going to get into some specific configuration options.
Thanks, Chuck. So what we're going to do now is basically address some of those pain points that we just heard about. So how do we deal with organizational control policies? How do we deal with actually configuring these resources? One thing I want to call out is that at this time last year, we had about a half a dozen, maybe a little more, services that had become HIPAA eligible. And for folks that don't know or are new in the healthcare space for AWS, the way that you can run a clinical workload on AWS is that you have to first sign something called a Business Associates Agreement, or a BAA. And part of what the BAA stipulates is that in order to store, transmit, or process PHI on the platform, you need to make sure that the service is included in the eligible services list. And as Chuck said, last year that was a more limited number. And what we've seen this year is an explosive growth in the number of services that we're adding. So much so that it's about a half a dozen now every month or so. And what you're going to see more moving in the future is that what we're going to be trying to do is make sure that when services are launched, that they will automatically be included in some of these compliance packages where we can. So first thing, how can I apply governance and controls to my account? So you've started this journey. You want to start allowing your researchers or your clinical staff to use the platform, but how can I actually control and govern that? So as Chuck mentioned, one of the functions that will enable you to do this is organizational policies. And the way we do that on AWS is through a service called organizations, or what we call orgs. So what organizations should be called out is that in terms of the HIPAA eligible services list, I think even as of today, you won't see organizations listed there. So a minute ago, I told you, you can't use services that are not on the eligible services list, and that's true. But in this case, remember what the rules of the BAA are. Does the service store, transmit, or process PHI? Now granted, you could name your account clinical patient number 1234, diagnosis X. I don't know why you would do that, but you could. That would be an example of incorrectly setting metadata on the service. But to use the service to actually orchestrate the services below it, absolutely you can do this without it being in the eligible services list. Remember that the way that AWS works is that we have a shared responsibility model. And so what that means is that AWS is responsible for the security of the cloud. We monitor and manage the infrastructure, the physical assets, the actual hardware that your infrastructure is running on. But you are still responsible for making sure that you've properly configured and hardened your environment. So the analogy I always love giving is that if you stood up a web application with a login portal and the login page had a user root and password 1234, that's not an Amazon problem. That's a customer configuration problem. So that would be an example of something that you might want to look at on your side. So how would we logically group accounts in an AWS organization? So the way that organizations works is that you create logical organization units, or OUs. And for folks that are familiar with sort of an Active Directory structure, the schema is very similar. You would create nested containers, or OUs, within your domain, and that's where we're going to actually place the accounts. An account can be a member of multiple OUs, and we're going to see why that's really powerful in a second. The way that Chuck was describing how an organization can control these accounts is through an organizational control policy. And this basically allows you to define things that an organization can do and the way that you want the account to be provisioned. And I think what you're going to see later this week is more services being added to organizations. So let me give you a quick example. What we have is a number of accounts here that are spread out through the enterprise. So in this case, what we have is an organization, that's the top level parent, in this case Acme Corp, and what we've created is 3 simple OUs, research, a HIPAA, and a public service OU. So we can see that we've got accounts spread through all the individual OUs, but they're all disparate, so they're just one level down. So one account in one branch, and that's pretty much it. And that's the way actually organizations first launched. What we want to do, though, basically, is make sure that when we take policy, that we can associate policy with the services. So in this case, I can attach a policy first to the higher level organization, which would be these are the services or the configurations that we want universally across all of our child accounts. So it doesn't matter if it's a clinical account, it doesn't matter if it's a security account, high risk, low risk. This is our baseline. All accounts must have this policy pushed down. So by nesting that on the top parent account, all lower accounts will get it. The next one that you see on the right side of the screen is a policy that's being attached to the far right group. So that would be basically a policy that's associated with A7, A8, and A9. So all the members within that organization would get that policy. Then we can make it more specific. We can say that we want a policy associated with just one account, in this case A9. And the way that the policy structure works is it's least permissive wins. So if you have a policy that gives an explicit deny on A9, but the organizational group gave an allow, the deny will trump. So now when we go to push those policies down, you can see that basically A9 would process the policy concatenation of all the policies. So the top level, the OU, and the policies that were attached to the actual account itself. And then the same would be true for the child accounts. So they would all basically be linked. And if we move an account to another organization unit, those policies would be copied over with it. So we can basically, in effect, get those policies attached now to A3. So a second example. So that hierarchy was a flat hierarchy. What happens if we want to do something a little bit more complicated? So in this case, we can see what I'm showing you is on the left-hand side, we have a structure for compliance accounts. And on the right-hand side, we've got a structure for research accounts. And we're doing the same policy push. But in this case, what I'm showing you is the color associated with the policy is what's actually going to be running on the lower accounts here. So in the compliance accounts, we've got a separate OU for HIPAA accounts, a separate OU for PCI accounts, and then on the research side, we've got clinical and non-clinical. And what you can see by sort of parsing the color codes is that D would basically get the clinical policy, the research account policy, and the Acme Corp policy. And whereas account F, for instance, would only get the concatenation of those two policies. So again, this enables you to make sure that services and APIs are allowed, or that you can explicitly block them. Can't be overridden by a local administrator. So if you're giving a local admin IAM permissions in that account, they actually can't override the permissions that you're setting. And it allows you to basically create an intersection between an IAM policy and a service control policy. And this has to be used in unison, though, with identity and access management policies to actually allow you to allow your operators to function. So a blacklisting example would look something like this. In this case, basically, I'm giving an explicit allow of everything, but then I'm saying that I want to explicitly deny the capability of using Redshift. So we have made the decision in our organization that we want to blacklist this service for whatever reason. This would be an example of us pushing a blacklist policy to say it doesn't matter for all resources below this OU or this account, you wouldn't be able to access Redshift. And even if you tried to give that permission at a local level or a local policy, the service control policy would prevent it. And on the other side, this is an example of an explicit whitelisting. So here, basically, I'm giving the same functionality for EC2, but in this case, I'm limiting the number of EC2 commands that can be authorized for a particular group or particular container. An important part that Chuck called out in his presentation was the need to have visibility from a security services account. So what I'm showing here basically is, if we think of it in that organizational policy, how can we apply a security account to an orgs group? So what we have here on the left-hand side is an account dedicated to security services, and this would have a read-only audit role that can be assumed in all the child accounts, so account A and account B. And the idea there is the positive part of using a read-only account oftentimes is that what you want as a security organization is the ability to capture the logs and metrics that allows you to perform your risk analysis as well as your job functions. But what some folks do when they first start adopting the cloud is that they're hesitant to allow you to join an organization, right? I don't want to put my account in your structure. You're going to tell me what I can't do. I don't want that. So using things like read-only access allows you to gain trust with that customer of yours, so you can say things like, well, look, this is read-only access. We're not going to go and modify your resources. This is just there to help us institute organization policies around governance and controls. Likewise, we can also configure those accounts then to do things like take their log data and push it into the security services logging bucket. The idea there is that if there is ever a breach or an issue with account security, in this case, the log data would be flowing instead of to the actual account, to the secure services account. So that way, if an adversary is able to get access to an account and privileged access, they can't go into S3 and delete all the log files. Likewise, we can do things like push SNS topics out for things like running scheduled operations like inspector, which we're going to cover a little bit later. So I get that. How do I deal with account access now? So the first part now that we've got the actual account is we can do things like use identity and access management, or IAM, and define who needs access to what. So there's a really important differentiation between giving a user console access and giving them programmatic access via the API with API keys. So you need to decide whether or not this user needs to have one or the other, and don't give them more permissions than what they actually use. As Chuck said for Beth Israel, the way to really do this at scale, though, is that you need to use some form of identity federation, because the more accounts that you start to add into your organization, individually managing IAM users and policies, it would be much more difficult to deal with synchronization than it would be to just use identity federation and allow those users to have a more pleasant experience by using the SSO portal that you've created to have them use a single credential that they're familiar with and not just one more username and password. You can also then embed things like your multi-factor authentication as part of that authentication mechanism. So if you're using a particular token provider, you can still continue to use the provider that you chose. And the way that the actual role is used, or the federated user is used, as Chuck mentioned, is it's an assumed role. So you assign a policy to that assumed role, and what the end user sees in the console basically is a punch out of the roles that they're allowed to assume. And the idea is that the reason that's powerful is you can give them the capability of doing a least privileged design. So the user can do things like just interoperate with S3 or just interoperate with a particular service rather than giving them star access to the entire fleet. An area where I see concern for some customers is, well, does a developer need access to IAM? They're a developer. Why would I give them access to this service? And the answer is normally no, but in some cases the answer is actually yes. And that's because they need to be able to perform some operations with a service like a CloudFormation template that may require that temporarily to provide that access. So again, the mechanism around that is that you could use an IAM role to give you, for the Linux crowd, the equivalent of like a sudo permission. So you can quickly elevate their permission set to run a CloudFormation stack, and then it drops that permission set once it's executed. The user might not be the only access boundary as well. So there's a design like Chuck had in Beth Israel's where they're using separate accounts to basically form logical isolations and boundary controls. So if we know that a particular researcher has a high-risk workload, we can give them a completely separate account and a separate network architecture to reduce the scope of that blast radius. So an example workflow. In this case, very similar to the prior example, we've got a developer that's going to be assuming an IAM role that gives an explicit set of permissions. And what they're doing here is basically executing a call to S3 where a CloudFormation template would be stored. That stack would run through the secure template that was blessed and authorized by your security operations team. And that now starts creating resources like a complete virtual private cloud, EC2 resources, network routing rules, security groups. And the benefit is that because you're using a CloudFormation template, if it's wrong, it's universally wrong. So every single time that this was deployed, it would always be deployed with that mistake. So you know where you need to go back and make changes. Whereas if things are done in a more manual, hand-created process, well then now you have to figure out, did we make this configuration for this account or this account? What about this account? If it's done programmatically, at least you know that universally everything was done in a particular way. Another important part for those developers is if you're concerned about making sure that they don't leak information, then simply don't allow the code to leave the environment. So in this case, what we're showing is a set of developers that are using Amazon Workspaces, which is our virtual desktop infrastructure or desktop streaming application service. And what they're getting is basically a desktop in the cloud where they can install all of their developer tools and work in an AWS VPC and allow them to directly interact with AWS services, but everything that's happening in that context is within AWS. So in plain English, the reason that that's really important is now you don't have the concern of, well, what happens if one of our developers has a laptop that even though we're supposed to be encrypting all of our laptops for policy, this one didn't. They put code on their personal device, and then the device got lost on a bus or someplace else. In a Workspaces environment, the only way that you can interact with it is through that Workspace client, which allows you to do things like integrate with your directory services, as well as things like multi-factor authentication. The other thing is that a Workspace environment does not push data over the wire. So we don't need to worry about an adversary actually looking at what the data is that's the developer is working on. What you're getting is basically pixels. So it's using the PC over IP protocol. So we're just moving pixels back and forth, not data. So that gives us the capability of making sure that our code stays in our environment. And then if we wanted to do things like make sure that we've got web application firewalls or things like threat detections within the resources, we can do that at the VPC level that has the Workspace enabled. IAM policy is really important in all these use cases because you need to know what are your users actually doing. So a lot of times you'll hear folks in AWS tell you, you should design for least permission or least privilege. And that's really easy to say. In practice, it's actually a little bit more complicated to do. So how do you actually know what scoping you need to do for these users? So what some users don't know is that a little while ago, we added a feature to the IAM console, which is the Access Advisor. That will allow you to go in and see what users, groups, and roles are actually doing on the platform. So you can see the services that they're actually interacting with and how long ago it's been. So a good example is if I created accounts a year ago, and after this talk, I'm going to go and look at this Access Advisor tab, and you see that the majority of your users are never using a select group of services, then why are you authorizing them to have it, right? It's one more thing now that you need to make sure that you have policy for. And in this case, what we can do is we can give them permissions exactly to what they're actually using based on the actual data that shows, no, you really are using these services. That's why we're going to give you that access. The other side is that all of this is flowing through CloudTrail. So we have all that rich data about the API calls that were made in the console, in the SDK, in the command line environment. All of that is being captured that we can use that to then filter to look for what are folks actually using as well. And there's actually a really good blog post that talks about how to use Athena to actually look at CloudTrail data and mine it for that same Access Advisor capability within IAM. Then things like password rotation, and again, we also provide you information about whether or not they're using things like their API keys. So if you're not using identity federation and you're providing individuals with discrete identity and access management users and API keys, it's a good opportunity to go and see, did you ever use that key? And if the answer is no, they've never used that key, then revoke it. And when they want it, they can go and ask you for it, but that's one less thing that you have to worry about accidentally leaking outside of your environment. It's also important to really use the tools that we're giving you. So things like Trusted Advisor. I don't see enough customers use this, and this is really low-hanging fruit. We'll give you information about, did you know that you have security groups open to the world, port 22 open to the world? Did you know that you have common misconfigurations that are outside of AWS best practices? If you have Trusted Advisor with business level support or higher, you can actually run these checks programmatically. So as part of your morning coffee routine, you can get the Trusted Advisor report and see, do we have misconfigurations in not only the root account, but we can run that same check through all of our child accounts as well. And then services like AWS Config to make sure that policy is being enforced universally through all of our services. So we have service control policies that make sure that users can't use services in the way that we want. We can use config as sort of a belts and suspenders approach to make sure that the meta configurations that we want are being enforced. So plain English, simple example. All EC2 instances must be tagged. You can create a config rule that will look for EC2 instances being launched that don't have a tag attribute, and then you can put it into a state of non-compliance. Now, some organizations will take a heavy-handed approach then and delete or terminate that resource. And what I would argue is, please don't do that. Generally, that causes bad blood between you and your end users. This is a better opportunity to get folks to understand why policies exist. So if you have a ticketing service that you're using, most common commercial ticketing services will allow you to interact with them via API. So as part of that CloudWatch or CloudTrail event firing, you can then use that to basically create an API request to your ticketing service and cut them a ticket. And because we can use the data from CloudTrail to know exactly who the user was, what the time was, what the service was, what the IP address was that they were on, we can use that as part of the ticket metadata to say that at this time, at this place, you made this call which was unauthorized. Please go back and make this change. OK, so I get it. We can create accounts. What about encryption? So healthcare and encryption go hand in hand very tightly. So how can we make sure that we're encrypting? So the answer is encrypt all the things, right? So AWS makes encryption really, really easy for you. So for services like S3, as Chuck mentioned, we heard from customers that we want a better way to make sure that all resources are encrypted by default. So now there's an option that you can enable so that S3 will encrypt all resources for you as part of the bucket level policy. For services like EBS, you can use config and config rules, again, to look for EBS volumes that don't have that encrypted attribute, as well as using templatized deployments. So Chuck said that one of the big things for Beth Israel was that they chose to use CloudFormation templates to deploy the resources. And if I remember correctly, it's because security wanted to vet the architecture, right? So as part of that, what your security operations team can do is basically provide sanitized, pre-blessed configurations that meet your security objectives. And one of those elements could be all of the EBS volumes that are created must be encrypted. And of course, there's a cadre of third-party monitoring tools that you can bolt onto the AWS platform as well that will allow you to do this. The actual mechanism for performing the encryption, services like KMS make this literally a checkbox operation for S3. You can also integrate that to services like CloudTrail to provide you with logging and auditable trails for compliance-related activities so that you can justify to your auditor to say that, yes, this resource at its inception was encrypted, and we can show through chain of custody all the way through that the device or the service was encrypted all the way through. It's important, though, to call out that usually when we talk about KMS, we just talk about encryption and keys. But the real power with KMS is not just the ability to create keys. It's the metadata that you can associate with grants. So grants allow you to set very fine-grained policies on exactly how the key can be used. So things like this key can only be used to perform an encrypt operation by these users, but a decrypt requires a separate permission and a separate context. So think about it from a situation where you have log data that needs to be retained for longer periods of time, and we need to make sure that only authorized people from our security team can actually perform a decrypt. We can set that through a grant. Likewise, if you have a requirement for having single-tenant capabilities for your encryption device, Cloud HSM, it's a FIPS 140-2 level 3 validated HSM. It allows you to perform cryptographic operations on a device that you are the sole tenant of. Another area that I don't see enough healthcare customers take advantage of is that we will give you SSL certificates at no cost. So the ACM service will give you free SSL certs that you can easily deploy to things like CloudFront, to the load balancers. It is literally a few clicks operations to get these. The nice part is that there's an automated renewal function. Doing things like creating a CSR request are not the most difficult thing, but at the same time, it's a place where I see a lot of customers make accidental misconfigurations in the way that they do it. And the ACM service kind of helps you make sure that you're actually creating the certificates the way that you think you are, and that they're being created and deployed in a way that actually allows them to perform their duty with little to no overhead. We talked about the capabilities for developers to develop securely on the platform. So a newer function is the EC2 parameter store. So an area, again, where I don't see enough customers taking advantage of this in the healthcare space is that it allows you to store secure code level attributes within the parameter store itself. So good example. Let's say I'm going to create a database server. And part of that database server deployment is I need to push the password to the database. So what does everybody do today? You bake it into like your Git repository. Maybe it's in your salt stack. It's somewhere in code, physically on a file somewhere, right? What's the problem with that? The developer will inevitably do something like check it into a code repository that's public, and now that key or credential has been leaked, and we have to go and do a full rotation. If it's stored in something like the parameter store, that code or that key basically would never be persisted to anything other than the memory of the resource, and it can be invoked at the time of the launch and then removed. You can create IAM policies very specifically to control that element so that only specific functions can actually authorize that parameter store value. And you can obviously encrypt it using KMS. So even if you were able to get the attribute out, the attribute would be stored in ciphertext, and the only way to perform a decrypt operation on that would be to have an authorized KMS key that would perform that decrypt. So now you have the capability of having a really strong password storage mechanism. So there's a really good blog post that we published that you can dive a little deeper on here, but it actually goes through exactly how to perform this. So how can I make sure that our environment now is securely patched? So this is another area for healthcare folks that's really important. So patching and enforcement and validation, we can use, again, EC2 Systems Manager now to actually automate the deployment of patches, scan instances for missing patches, and make sure that we're compliant. So today, there's usually a cadre of solutions that I see in most healthcare customers where they're using some solutions for this platform, some solutions for this platform. Hopefully they all work, sometimes they don't. With the EC2 Systems Manager, it gives you the ability to have a more single pane of glass that we can use across the fleet to look for non-compliance. Another really powerful function for more technologically advanced customers is that you can effectively remove shell access from servers as well. So we hear things like, we want to allow Bastion and hosts to connect with hosts so that we can perform SSH operations. Well, why give them that capability at all? Instead, we can use the EC2 run command through the Systems Manager tool to actually run those commands as an API call. And the reason that that's a really powerful tool is, everybody remember Jurassic Park? The Nedry guy, and at the end he types in the code white rabbit, and then suddenly we don't know what he does. So that same technique is used in a lot of malware payloads, where they'll activate something that allows them to mask the commands that are being run. So from a forensics capability, it's much harder to figure out what they did. In this case, if we remove that shell access altogether to the host, any calls that are made to the instance, well, those are API calls. And because it's an API call, that means it's going to flow through CloudTrail, which means now we have the capability of seeing every single command that was executed on this particular host, by whom, from where, and under what context. So this is a really strong way to make sure that basically folks don't have more access than what they actually need. We can also do things like use Inspector to schedule assessments for compliance. So if we have an environment where we want to look for, do our EC2 fleets have a susceptibility to a common CVE that was just announced? Do they have misconfiguration against AWS best practices? Inspector can give us that information in a more programmatic and automatic way. So now, how do I make sure that the network is secure? So some of the elements that Chuck talked about for what Beth Israel did is they created an environment where effectively they're tunneling all their traffic back through on-prem. And some customers are doing that very much when they're looking at a hybrid workload for AWS, where they treat AWS as an extension of their on-prem facilities. But for customers that are trying to publicly expose clinical applications for their customers or clinical care capabilities, If you want to publicly expose them, we want to make sure that they're properly safeguarded and hardened. So in this case, we can do things like using Route 53 for our DNS control, and then leveraging things like a CloudFront distribution so that only valid, let's in this case say layer 7 traffic goes through to our hosts. And then we can also couple that with things like services like WAF and Shield. WAF is our web application firewall service, so we're looking for things like SQL injection, bad bot detection. Shield is our anti-DDoS service. So looking for things like, an adversary out there is sending you a note that says, if you don't send us 50 Bitcoin, we're going to take your service offline. Shield can help mitigate those resources. And if you want access to dedicated DDoS experts, there's a Shield Plus service as well that can help you actually talk to an engineer during an event, and as well as do things like get cost recouping. So these capabilities basically coupled with things like VPC flow logs to actually capture the equivalent of net flow information that's taking place on the platform to see, is this EC2 instance talking to hosts in the way that I think it is, or do I have an EC2 host that's running port scans within our environment? If we analyze those flow logs, we can actually see all the traffic that's happening in our environment. And the reason that really kind of came about, to be transparent, is when we talk about things like security groups, we tell you that if there's a deny, we drop the traffic. Well, what customers wanted to see is, I really want to see you drop that traffic. So with flow logs, if you actually look at your VPC flow log, you can actually see the deny traffic. And the reason that that's really powerful is that if we chain that with some of the automation techniques that we've talked about, we can do things like automatic remediation or automatic incident response. So if I see an internal host that's performing things like port scans or trying to talk to another EC2 instance internally on a privileged port and getting a deny, I can use that as a kickoff event for things like creating an incident response where we snapshot the volumes, maybe start capturing logging information, memory execution, all that good stuff. So how many folks here are from an academic institution or educational institution? Okay. So what a lot of these customers don't know is that when we talk about healthcare, 853 comes up a lot. What most people aren't focusing on right now is 800-171. So if you are an academic or educational customer, if you don't know it or not, at the end of December, you will be required to comply with 800-171. 800-171 basically is for controlled unclassified information, and you're thinking to yourself, well, we don't really do that. Well, if you actually look at what the descriptor for what controlled unclassified information is, one of those elements is student records. So how can I actually be compliant with some of these frameworks when we don't have that in-house expertise? And the answer is that we provide you with some templatized architectures that use CloudFormation templates. You can access them in this portal, which is the Quick Start portal. And in this case, what I'm showing you here is the NIST Quick Start portal. This will give you an environment that's been pre-configured for 853, 800-171. It gives you sort of a nice 3-tier web architecture. But the part of that tooling that's actually really, really powerful outside of that CloudFormation template is that arrow that I'm showing on the lower part of the screen, the service security control matrix. So that gives you basically a complete mapping of the framework and explains to you via the template where AWS is responsible for that control and where you are responsible for that control. So if nothing else, if you have an institution that needs to comply with these frameworks and they don't know exactly whose responsibility it is, using that security controls matrix can really help with that process. So how do we deal with audit now? So just kind of quickly running through some of these services. These are the core services that you're going to be using for audit operations. So things like logging and auditing, we would be using services like CloudTrail really heavily. Asset management, things like AWS config, and we can use the native AWS API or CLI to do describe calls to our environment. For configuration, we can make sure that we're using things like the CLI or API correctly, as well as providing our end users with pre-configured SDKs. So think about that workspace environment that I told you about earlier. We can pre-bake that workspace image to have the SDKs or the CLI agent that you want so that they don't have to go and reconfigure things. It's already pre-made and pre-blessed for you. How can we deal with things around encryption and key management? So for data in flight, IPsec or TLS or choose your own solution. Volume encryption, again, services like Amazon EBS encryption, literally checkbox. If you don't want to use the KMS-based service, you can use Cloud HSM, or you can roll your own. We don't dictate to you how you have to meet your requirement. Every customer is free to make the choices that they choose as being most easy for their risks acceptance and most easy to actually deploy at scale. So we don't actually force you to do one way or the other. Network controls, again, we talked about things like accessing services through Direct Connect. So if you don't want these services to be publicly exposed, but we want to make sure that we have a dedicated high-speed, low-latency link, we can use Direct Connect so that all that traffic is flowing directly back on-prem. And then if we want to do things like deep packet inspection or use existing hardware that we've made an investment in, you can plumb that directly in line with your Direct Connect circuit, just like Chuck was describing for what they do with their environment. IDS, IPS, so these are areas where I see a lot of questions for customers. So CloudTrail and CloudWatch gives you a lot of information about how the environment is being used. And then again, services like VPC Flowlog will give you really rich information about how that network is actually being used within your environment. Okay, so I get all this. You've told me all these different ways. How do I actually get help for my environment now? So these are all really generalized terms. I need help with our configuration. So AWS, if you know it or not, if you have an account right now in AWS, you actually have a dedicated SA for your account. And that SA is available to you at no cost. So a solutions architect can come in and provide you with guidance about, is this architected for cost correctly? Is it architected for security correctly? Are we following best practices? They can give you all of that information at no cost and make sure that you're actually configured in a way that meets your requirements. If you want to go a little bit deeper, we need help actually deploying a solution. So we want to use services like CloudFormation, but we don't have in-house expertise to actually do that. How can we do that? Services like AWS Professional Services can allow you to accelerate that process by bringing in dedicated Amazon folks that have that specialty to help your team either come up to speed quickly on that service or to help you actually create solutions for it. And then, of course, as you'll see on the Expo Flow, there are a number of partners specific to the healthcare space now that can actually help you deploy applications with guardrails specific to healthcare configurations. So making sure that you're properly configured for a HIPAA or HITRUST configuration. How do I see the AWS BAA thing that I talked to you about earlier? It used to be that you had to actually track down your account manager and then request access to it. Good news, we don't make you do that anymore. There is a service that we launched a little bit midsummer this year called Artifact. Artifact has the BAA in it now, so you can actually get the BAA document from the Artifact service. It does require that you click through the account in the account that you actually own and sign a non-disclosure click-through. But that will give you actual access to the BAA, so if you've never seen it before and you want to read it, you can actually now go and request access to it, as well as other security documents from AWS, such as our ISO reports, SOC reports. All those things used to be required to actually go through an individual. You can get them all through Artifact now. So in summary, automation is something that's really important for folks that are in the healthcare space. Beth Israel talked about how they're using services like CloudFormation to ensure that they're meeting their objectives by forcing this policy through. But when we look at things at a larger scale, that's where you want to look at automation through services like organizations or using read-only access roles within your environment to make sure that your environment is configured the way that you think it is and that you are meeting your security objectives. Like I said, make sure that you're reaching out to the free resources that AWS gives you. There's a whole blog that's dedicated to healthcare information for AWS as well. And generally speaking, all of the blogs that AWS puts out, these are not put out by folks that are trying to market to you. Most of them are written by folks like me or other engineers, where we're actually trying to give you actual technical information that you can use in your account and not just, there's a new service that's coming out, it's got, sparkles. So with that, that's all that we have for you. We're going to stick around up here and answer any questions that you guys have for you. But if you don't want to hang out for that, you're free to go to the next session. But otherwise, thank you very much.